Hello all, let us see how to solve this particular problem. So basically what is given here is a two-port resistive network where there are two ports and there is simple resistive network that is provided, and the first condition is when the excitation of 5 volts is provided across port 1 and port 2 is shorted, so the current is seen as 1 amp in the shorted port. And then now if an excitation is provided across port 2, that means this side, and the port 1 is shorted, we just need to calculate the current. So this is a simple problem. So now if you see, basically the ultimate aim is to calculate the current that is crossing this node, passing through this node. So and to calculate this current, we definitely need to calculate the resistance. Then we can calculate the current here. So for that, first let us use the first network to calculate the resistance. So as the current is passing through this direction, and the source is in direction, right? So the current would be passing from this node, from the source towards this node, and the current will be passing this way. So now if you use a Kirchhoff's law in the bigger loop for the first node using KVL, Kirchhoff's voltage law, so minus 5, let us assume that the current here is I, okay, plus I into 1, because V is equal to I into R, plus here V is nothing but I into R, which is 2 into 1, which is 2 volts, right? 0. So that means I into 1 is I, plus 2 is equal to 5. This gives I is nothing but 3 amps. So the current that is sourced from here is, from the source, is 3 amps. We know that this is 3 amps and this is 1 amp. That means the current passing through this node is 2 amps. So now using Kirchhoff's law in this loop, so this is plus minus because the current is passing here, this is plus minus. So using KVL in that loop, minus R, because R is the resistance, and 2 amps as we said into 2 is nothing but IR. And when you go to this loop, again plus 2 into 1 is equal to 0, which gives R is nothing but 1 ohm. Okay, so the resistance is calculated as 1 ohm here. So here the resistance is 1 ohm. So if you see this circuit would be this way. This is 1 ohm and this is 1 ohm and this is 2 ohms and this is 5 volts. Okay, so now here we have to calculate the current here. So for calculating the current here, we just need to know what is the total current that is sourced from here. So if you calculate the equivalent resistance of this circuit to calculate the current I here, so 1 and 1 are parallel. That means 1 and 1 are parallel is nothing but 1 into equivalent resistance, 1 into 1 by 1 plus 1, R1 into R2 by R1 plus R2, which is nothing but 1 by 2, which is 0.5, right? So that means if two same resistances are in parallel, that is R by 2, so 1 by 2, 0.5. So the circuit will be this way now, 0.5 and then 2 ohms, and then we are applying the 5 volts here, right? So the circuit is this way. So now these two resistors are in series. That means the total resistance is 2.5. So if you want to know the current out of this source, I is equal to V by R, right? V is nothing but 5, current is nothing but 2.5, which gives 2 amps. So the total current out of this node, 5 volts node, is 2 amps. So here the current is 2 amps, because out of this 5 volts the current coming is 2 amps. Now this is 1 ohm, this is 1 ohm. That means the equivalent resistance seen by this current coming here is same. So the current gets divided equally. So 2 gets divided equally. That means this will be 1 amp and this will be 1 amp. So the current that is passing through the shorted node is nothing but 1 amp. This is how we calculate the current. Thank you.